GIT, GitHub, and GIT Actions version control for machine learning. Let's break down how GIT, GitHub, and GIT Actions, all related to version control, play a crucial role in machine learning projects. 1. GIT, the foundation of version control. GIT is a powerful distributed version control system (DVCS). It allows developers to track changes. GIT records every modification made to the codebase, enabling you to see who made what changes and when. Branch and merge. Developers can create branches to work on new features or bug fixes without affecting the main code. These branches can then be merged back into the main branch, ensuring a smooth collaboration process. Rollback. If a change introduces errors, GIT allows you to easily revert to a previous version of the code. Collaboration. GIT facilitates teamwork by allowing multiple developers to work on the same project simultaneously, merging their changes effectively. 2. GitHub, the collaborative hub for GIT. GitHub is a web-based platform that provides hosting for GIT repositories. It offers various features crucial for machine learning projects. Repository management. GitHub allows you to store your project's code, data, and models in a centralized location. Collaboration tools. GitHub provides features like issue tracking, pull requests, and code reviews, fostering efficient communication and collaboration among team members. Community and open source. GitHub is home to a vast community of developers, making it easy to find and use open source machine learning libraries, datasets, and models. Version history. GitHub stores the entire history of your project, enabling you to easily revert to previous versions or track the evolution of your codebase. 3. GIT Actions, automating machine learning workflows. GIT actions are automated workflows that can be triggered by events in your GIT repository. This makes it an essential tool for machine learning projects. Automated model training. You can set up GIT actions to automatically train your machine learning models every time new data is added or changes are made to the code. Continuous integration and deployment. CI/CD. GIT actions can automatically run tests, build your model, and deploy it to production, ensuring a streamlined and reliable development process. Model monitoring. GIT actions can be configured to monitor the performance of your deployed model and trigger alerts if performance degrades. Experiment tracking. You can use GIT actions to track and compare different model training experiments, making it easier to find the best performing models. In summary, GIT provides the foundation for version control, allowing you to track changes, branch, merge, and collaborate efficiently. GitHub offers a centralized platform for storing and managing your code, facilitating collaboration and access to open source resources. GIT Actions automates repetitive tasks like training models, running tests, deploying models, and monitoring performance, streamlining your machine learning workflow and increasing efficiency. By leveraging these tools, machine learning projects can be developed more effectively, collaboratively, and reliably, leading to better models and faster time to deployment. GIT, GitHub, and GIT Actions for machine learning. GIT, a version control system (VCS) essential for managing code changes. It allows you to track changes, revert to previous versions, and collaborate effectively. GitHub, a web-based platform that provides hosting for GIT repositories. It offers features for collaboration, issue tracking, code review, and project management. GIT Actions, a continuous integration and continuous delivery CI/CD tool hosted on GitHub. It automates tasks like building, testing, and deploying machine learning models, Use cases in machine learning. Code management. GIT helps track model development, experiments, and hyperparameter tuning. Branching and merging allow for parallel experimentation and code integration. Collaboration. GitHub facilitates teamwork by enabling multiple developers to work on a project simultaneously, track each other's progress, and discuss ideas. Bug tracking. GitHub Issues provides a centralized platform for identifying, tracking, and resolving bugs in machine learning models. Code review. GitHub pull requests allow for thorough code review, ensuring quality and maintainability. This is especially critical for complex ML projects. CI/CD with GIT actions. Automated training. Train models automatically on new data using GIT actions. Model testing and evaluation. Run tests and evaluate model performance as part of the CI/CD pipeline. Deployment. Deploy trained models to production environments seamlessly. Versioning. Track different model versions and their performance metrics for comparison. Example: imagine a team developing a machine learning model for image classification. GIT. They use GIT to manage the codebase, track changes, and experiment with different architectures and hyperparameters. GitHub. They collaborate on the project, share code, discuss ideas, and track issues using GitHub. GIT actions. They use GIT actions to automatically train the model on new data, test its performance, and deploy it to a web service for users. Benefits: improved efficiency, streamlined collaboration, and automated processes reduce development time. Enhanced quality. Thorough code review and automated testing ensure model quality. Increased reproducibility. GIT and GitHub allow for easy tracking and replication of experiments. Streamlined deployment. Automated CI/CD ensures consistent and efficient model deployment. Conclusion: GIT, GitHub, and GIT actions are essential tools for modern machine learning development, enabling efficient collaboration, code management, and automated model building and deployment. GIT, GitHub, and Milliliter. A collaborative workflow. GIT is a version control system, essential for tracking changes in code and collaborating on projects. GitHub is a popular platform hosting GIT repositories, enabling collaboration, code sharing, and community interaction. Here's how these tools integrate with machine learning. 1. GIT actions inputs. These are customizable parameters that control the behavior of your GitHub Actions workflows. In Milliliter, this allows you to specify hyperparameters for model training, select different datasets for experimentation, define evaluation metrics for model comparison. 2. Code files. Your machine learning projects involve numerous files. Model code. Python scripts defining your model architecture. Data preprocessing scripts for cleaning and preparing your data. Training and evaluation scripts. Code for running experiments and analyzing results. Configuration files storing settings for data paths, model parameters, etc. GIT tracks all these changes, enabling you to easily revert, compare versions, and collaborate. 3. Commit messages. Effective commit messages are crucial for maintaining a clear history of your project. In Milliliter, commit messages should describe the changes made, e.g., added new dataset, improved model performance, briefly explain the rationale behind the change, e.g., increased accuracy by 2, help others understand the evolution of your project. 4. Branch names. Branches allow you to work on separate features or bug fixes independently. For Milliliter projects, use descriptive branch names. Feature branches feature new model. Feature data augmentation. Bugfix branches bug fix performance issue. This helps maintain clear organization and prevents accidental merges. 5. Tags. Tags are used to mark specific points in your project history, often associated with releases or important milestones. In Milliliter, you can use tags to tag trained model versions, model versus 1.0, model version 2.0. Tag dataset versions, data the 15th of April 2023. Tag code versions used for specific experiments. Benefits of using Git and GitHub for Milliliter. Version control, track changes, revert to previous states, and understand the development process. Collaboration, share code, collaborate on projects, and benefit from community contributions. Reproducibility, easily replicate experiments and results. Documentation, well-structured commit messages and branch names provide valuable documentation. By embracing Git and GitHub, you can streamline your machine learning workflow, foster collaboration, and ensure a robust and traceable development process. Git, GitHub, and machine learning, a collaborative workflow. Git is a version control system that helps track changes in code and data. In the context of machine learning, it enables code management, versioning your model, training scripts, pre-processing pipelines, and other code related to your Milliliter project. Collaboration, multiple researchers or engineers can work on the same project, merging their changes and resolving conflicts seamlessly. Experiment tracking, storing different model architectures, hyperparameter settings, and dataset versions for future comparison and analysis. GitHub is a platform built around Git, providing code hosting, storing your ML project's code and data on a remote server. Accessible to collaborators. Issue tracking, organizing and managing bugs, feature requests, and tasks related to your project. Collaboration tools, facilitating communication and collaboration with features like pull requests, discussions, and project wikis. Continuous integration, delivery, CI/CD, automating tasks like building, testing, and deploying your Milliliter models with tools like GitHub Actions. Git Actions outputs are a powerful tool for CI/CD workflows within GitHub. They allow you to automate model training, trigger model training upon code changes, pushing updates to your model, and uploading it to a registry. Performance evaluation, run automated model evaluation after each training run, capturing metrics like accuracy, precision, and recall for tracking progress. Deployment, deploy your trained models to different environments, e.g., production. Staging, using actions. Code history allows you to track changes, view the history of all modifications made to your code, including who made them and when. Roll back to previous versions, revert back to earlier versions of your code, allowing you to experiment without breaking the current state. Understand model evolution, analyze how your model has evolved over time based on code changes. Hyperparameter tuning and dataset updates. Diffs are the differences between two versions of your code or data. They allow you to review changes, understand the impact of specific code modifications or data updates before merging them. Identify potential errors, spot potential issues by analyzing code changes and data modifications. Analyze model performance differences, compare the effects of changes on your model's performance by examining diffs in training scripts and hyperparameters. Branches are parallel lines of development within your project. They allow you to work on separate features, isolate development of new features or bug fixes without affecting the main code base. Experiment with different approaches, explore different model architectures, hyperparameter settings, or data preprocessing techniques without disrupting the current version. Test and merge changes. Thoroughly test features or fixes in a branch before integrating them into the main code base. Tags are labels that mark specific points in your project's history. They help you identify important releases, mark significant milestones or releases of your milliliter model, providing a clear reference point. Release-specific versions create tags for each model version, allowing for easier deployment and tracking. Document model updates. Associate tags with documentation describing the changes made in each model version. By leveraging these features of Git, GitHub, and Git Actions, machine learning practitioners can establish a robust, collaborative, and reproducible workflow for their projects. This streamlines development, improves communication, and ensures reliable model management and deployment. Git, GitHub, and Git Actions in Machine Learning. A guide. Git, GitHub, and Git Actions are essential tools for any machine learning project. They allow you to track changes. Git acts as a version control system, meticulously recording every modification you make to your codebase, enabling you to trace the evolution of your milliliter project. Collaborate efficiently. GitHub provides a platform for hosting your Git repositories and facilitates collaboration with your team members. It allows for shared code management, discussions, issue tracking, and code reviews. Automate tasks. Git Actions offers a platform to automate repetitive tasks like building, testing, and deploying your milliliter models, saving time and ensuring consistency. Let's delve into some key commands. 1. Git commands. Adds changes from your working directory to the staging area. Git add stages all modified files. Commit records changes from the staging area into your local repository. Git commit m descriptive commit message creates a snapshot of the project state. Push uploads local commits to a remote repository, usually on GitHub. Git push origin main pushes your local commits to the main branch on your remote repository. Pull downloads changes from a remote repository to your local repository. Git pull origin main fetches and merges the latest changes from the remote main branch. Checkout switches between different branches or commits in your repository. Git checkout main switches to the main branch. Merge combines changes from one branch into another. Git merge feature merges the feature branch into the current branch. Revert undoes a specific commit without modifying subsequent commits. Git revert commit hash reverts the specified commit. 2. Machine learning specific applications. Experiment tracking. Use Git to track different hyperparameter settings, data sets, and model architectures, allowing for reproducible experiments. Code sharing. Share your milliliter code with collaborators using GitHub for feedback, review, and joint development. Deployment automation. Utilize Git Actions to automate the deployment of your trained milliliter models to production environments. Model versioning. Tag your Git repository with different model versions, providing a traceable history for model updates and analysis. 3. GitHub repositories. Store your milliliter code and data in GitHub repositories, providing a central hub for your project. Collaboration tools. Utilize GitHub's features like issues, pull requests, and discussions for seamless team collaboration. CI/CD integration. Integrate GitHub with CI/CD platforms like Git Actions for automated builds, tests, and deployments. 4. Git Actions workflows. Define workflows in YAML files to automate tasks like training models, running tests, and deploying models. Triggers. Trigger workflows based on specific events, such as code pushes, pull requests, or scheduled intervals. Environment variables securely store sensitive information like IP keys and credentials within workflows. By leveraging Git, GitHub, and Git Actions, you can efficiently manage your machine learning projects, fostering collaboration, streamlining workflows, and enhancing reproducibility. Git, GitHub, and Git Actions for machine learning projects. Git is a version control system, a powerful tool to track changes in your code and collaborate with others. GitHub is a platform that hosts Git repositories, providing features for version control, collaboration, and code sharing. Git Actions automate tasks within your workflow, including building, testing, and deploying your machine learning models. Steps for using Git, GitHub, and Git Actions in machine learning. 1. Initialize repository. Git init creates a new Git repository in your local directory. GitHub create a new repository on GitHub and get its URL. Machine learning. This step initiates version control for your project, including code, data, and models. 2. Track files. Git add file adds files to the staging area, preparing them for commit. Use Git add to add all files. GitHub files added to the staging area are also tracked on GitHub. Machine learning tracking files ensures a record of your code changes, data pre-processing scripts, model training and evaluation results, and potentially trained model files. 3. Commit changes. Git commit mcommit message saves the changes in the staging area to the local repository. GitHub commits are reflected in your GitHub repository's history. Machine learning committing changes provides a snapshot of your project at a specific point in time, allowing you to easily revert back to previous versions. 4. Push to remote. Git push origin branch uploads your local commits to the remote repository on GitHub. GitHub pushes update the remote repository, making your code accessible to collaborators. Machine learning pushing changes allows sharing your work with others, ensuring collaboration and reproducibility. 5. Pull updates. Git pull origin branch retrieves changes from the remote repository and merges them into your local branch. GitHub pulling updates ensures your local repository remains in sync with the remote version. Machine learning pulling updates ensures you are working with the latest code, data, or model changes, preventing conflicts and ensuring consistency in your project. Git Actions for machine learning. Git Actions can be used for various tasks in your machine learning workflow. Automated training and evaluation trigger model training on a schedule or after code changes. Continuous integration and deployment. CI/CD automate model deployment to different environments, e.g. cloud platforms. Data versioning automatically update data versions after pre-processing. Hyperparameter tuning automate experiments with different hyperparameters. By leveraging Git, GitHub, and Git Actions, you can streamline your machine learning projects, collaborate efficiently, and ensure reproducibility and scalability. Git, GitHub, and Git Actions in machine learning. Git is a version control system (VCS) that allows you to track changes in your code over time, making collaboration and managing projects much easier. It's essential for machine learning projects, as they often involve complex codebases and multiple contributors. GitHub is a platform that hosts Git repositories and provides additional features like collaboration tools, issue tracking, and continuous integration, continuous delivery CI/CD workflows. Git Actions is a CI/CD service built into GitHub, allowing you to automate tasks like testing, building, and deploying your machine learning models. Here's how these tools address common challenges in machine learning. 1. Challenges fixes. Conflicts. Resolve conflicts. GIT helps identify conflicting changes when merging branches. You can manually resolve them by choosing the desired changes from both versions. Use branching strategies. Implement strategies like GIT flow or trunk-based development to minimize conflicts and ensure smooth collaboration. Merge conflicts. Manually resolve conflicts. GIT provides tools for visualizing the conflicting changes and choosing the desired version. Branching strategies minimize merge conflicts by using feature branches for individual tasks and merging them regularly. Data loss. Backup repository. Regularly backup your repository to a separate location to prevent data loss. GitHub's version history. GitHub keeps track of all changes made to the repository, allowing you to easily revert to previous versions if needed. Security vulnerabilities. Use secure protocols. Utilize HTTPS to secure communication with GitHub and ensure data integrity. GitHub's security features leverage features like two-factor authentication and private repositories to protect your code. Performance issues. Optimize repository size. Use GITLFS large file storage to store large files like datasets separately, reducing the overall repository size. Optimize workflows. Streamline your GIT Actions workflows to reduce execution time and improve performance. Collaboration issues. Use clear communication channels. Employ tools like GitHub issues, pull requests, and discussions to facilitate efficient communication and collaboration. Learning curve. Refer to documentation and tutorials. GitHub offers extensive documentation and tutorials specifically tailored for machine learning projects. 2. Machine learning specific considerations. Versioning models. GIT allows tracking changes in your trained models, ensuring you can easily revert to previous versions or compare different model iterations. Data management. GIT can manage large datasets, but for optimal performance, utilize GITLFS and consider data versioning tools specific to machine learning projects. Reproducibility. By leveraging GIT, you can ensure reproducibility of your machine learning experiments, enabling others to replicate your results or build upon your work. 3. Benefits of GIT, GitHub, and GIT Actions in machine learning. Efficient collaboration provides tools for seamless collaboration among team members. Version control tracks changes and allows reverting to previous versions, ensuring code stability and reproducibility. Automation automates tasks like testing, building, and deployment, freeing up time for more creative work. Continuous integration deployment. CI/CD streamlines the development process by automating code testing and deployment, leading to faster development cycles. Community and resources provides access to a vast community of developers and resources specific to machine learning. By utilizing these powerful tools, machine learning practitioners can streamline their workflows, improve collaboration, and build better models, ultimately contributing to the advancement of the field.